One of the key things we do with surds when we're dealing with fractions is rationalise the denominator. There's something like this: 4 on the square root of 2. Does anyone know why we bother rationalising the denominator? Why do we do it? Why are we obsessed with it? That could be a reason. Easy to approximate the number. But I would say no, there's actually a better reason than that. The reason, I guess, is comparison. Right? Because if some surds you've got surd on the top of the fraction, some you've got it on the bottom, it makes it very hard to compare the numbers. Certainly makes it very hard to add the numbers. So we tend to go, well, let's have a rational number in the denominator. Now, having said that, I'm now going to, I guess, sound like a hypocrite now. I'm going to say I'm not obsessed with rationalising the denominator. I see nothing wrong with leaving an answer. Well, that one simplifies down, but I see nothing wrong with leaving a surd in the bottom of the fraction. It's a number just like any other number. And I guess it all comes down to what are you going to do with the number? If you want to compare numbers, or as you say, if you want to approximate, yeah, it's probably easier to do it that way. So let's look at this one, 4 on root 2. How do we do it? Well, we get rid of the problem. The problem is we have this irrational number on the bottom. How do we make the irrational number rational? We'll multiply it by itself, because we know they will cancel each other out. Can't change the question though, so whatever we do to the top of the fraction we have to do to the bottom. We get 4 root 2 on 2, which is 2 root 2. When there is something like 2 root 5, just to highlight, you don't have to square 2 root 5. It's only the bit that's causing you the problem you want to get rid of. So it's root 5 we multiply by. Now, it's not wrong to multiply by 2 root 5 on 2 root 5. It just means you'll end up having to do some cancelling later on to simplify the fraction down. 2 terms, and this is where the conjugate becomes important, because simply multiplying by root 2 is not going to fix the problem, because when I multiply 1 by root 2, I'll get root 2. I've still got it in the bottom. And so the conjugate comes in handy, because as we just saw, what happens when we multiply conjugates together? Get difference of 2 squares, so the problem goes away. Multiply by root 2 plus 1 on root 2 plus 1. So on the bottom we now have 2 minus 1, which is 1. We have our answer. And one more. Let's do this one. I love this sort of question where on top you've got conjugates and things like that anyway, and then you multiply by the conjugate and you get a perfect square on the top and a difference of 2 squares on the bottom. And by the way, I don't want you thinking that the denominator always turns out to be 1. It's just a coincidence. That was also 1 as well. So 7 plus 4 root 3, and that will do us.